Hello students, welcome to JCE Connect series of lectures. In this particular session, I will be discussing about orifices and mouthpieces, and this particular chapter is just a continuation of module number 4. So where in that module we have already completed notches and wears. The continuation of that module only, that is orifices and mouthpieces. So in this particular chapter we are going to discuss about definition of orifice, classification of orifices, advantages of orifices, and that is a difference between orifice and mouthpieces. Again, for mouthpieces, the definition, classification, and advantages and disadvantages we are going to discuss in this particular chapter. So let us start with the introduction part. So what is orifice? Orifice is a small opening of any cross section. Means it could be a circular, it could be a triangular, it could be a rectangular, and it is provided on the side or at the bottom of a tank through which a fluid is flowing. And if you look at the definition of mouthpiece, it's a short length of a pipe which is 2 to 3 times its diameter in length, fitted in the tank or a vessel containing the fluid. And both orifices and as well as the mouthpieces are used for measuring the rate of flow of fluid. As I said, an orifice is an opening having a closed perimeter like this. Just look at this picture, so you can easily understand by looking at this picture. It will be a closed perimeter made in the walls or bottom of a tank or a vessel containing a fluid through which the fluid flows. Means just to try to understand, orifice is nothing but an opening of any cross section. It could be a circular in shape, or triangular, rectangular, or any other shape. Just it's an opening provided on the side of a tank or at the bottom of the tank, just to draw the liquid or to transfer liquid from one tank to the other tank. The best example we can give just your own house overhead water tank. So for the overhead water tank, if you want to draw water, at the bottom a opening is being provided. Through that opening the pipe will be connecting, and you will be getting water through that pipe in various places. So it just look at this picture. Is a water tank, and here just here look at this one. Here opening is provided, that is just a hole is provided here. This is nothing but a orifice. Okay, so when once a hole is provided, then the orifice plate will be fitting like this, just to draw the water. Okay, this is called orifice. And orifice is a small opening of any cross section. Any cross section such as circular means it could be of any shape, circular, triangular or rectangular, on the side or at the bottom of the tank through which a liquid is flowing. It is called as a orifice. So one more is a mouthpiece. A mouthpiece is nothing but just an extension of an orifice. So orifice is in flush with the tank surface, tank wall surface, but whereas mouthpiece, it will be like this, just an extension. It is extended outward of the tank, or it could be inward. It's a short length of a pipe which is 2 to 3 times its diameter in length. Means this length of the tube will be 2 to 3 times the diameter of the orifice. This is the diameter of the orifice, and the length of the tube will be this. If you measure, it will be 2 to 3 times its diameter. This is diameter and this is length. This is length and this is diameter. So this length of the tube will be 2 to 3 times the diameter of the orifice. 2 to 3 times its diameter in length, fitted in a tank or a vessel containing the fluid. And this is also used to just to draw the liquid from the tank. And these both orifices as well as mouthpieces are used for measuring the rate of flow. Means how much quantity of liquid will be flowing through the tank. To know that one, these kind of devices will be used for a measuring purpose. So like this, these are the just liquid storage tanks of different quantities. Okay, so 10,000 liter tank or 7,500 liter tank, like this, that various size tanks available in the market. And at the bottom of the tank a hole will be provided, or at the side of the tank, just to draw the liquid, and that opening what we call as a orifice, and the extension of an orifice is called as a mouthpiece. And mouthpiece will be having a length, that is the tube length will be 2 to 3 times the diameter of orifice. Okay, let us move to the next one. In this particular here, let us define a term called as vena contracta. So this is very, very important, this term vena contracta. And this type means a jet, whatever the jet is coming out of the orifice. As I discussed earlier, a orifice is nothing but an opening provided on the side of the tank. Here a orifice is provided, and this is the tank filled with the liquid. And if you measure the depth of water from the center of the orifice, let us call it as a H. Whenever the depth is more in the tank, the pressure is more at the bottom, as you know from the hydrostatic law. Because of the high pressure, what happens, the liquid will come up with that is a high velocity jet. Like this, jet of liquid will come out through the orifice. While coming out, so the water particles, or you can call it as a streamline of liquid, may get contracted. So the veins, these are called as the veins of the liquid, which get contracted initially, then they get diverges. Initially they contract, then they get diverge, and hence the initial contraction of liquid, what we call as a vena contracta. Veins get contracted, hence the name is vena contracta. So in a liquid jet, where the streamlines means the continuous flow of water or uniform flow of water becomes parallel, means just look at this picture. Here a streamline means the water is coming out of the orifice. Just see the picture of the orifice here. This is a sharp edged orifice. While coming out, the streamlines will get contracting initially, then they get attracted towards the gravity. Means the water will be falling down like this. See, look at this picture. See, this is the beveled edge, and this is the vena contracta portion, or the point, or the region. So the streamline becomes parallel and perpendicular, means all these streamlines will be parallel to each other and they are perpendicular to the plane of the orifice, is termed as vena contracta. And the cross section area of jet at the vena contracta is less than that of the orifice. Means this is the original size, means this is the diameter of the orifice. You can call it as a diameter of orifice as a DO. And if you take this portion, this is the diameter of contracted portion. This diameter will be less than the diameter of the orifice. Means the jet is contracting here. When it contracts, automatically the diameter will get reduced here, and this region diameter will be lesser than the diameter of the orifice. Hence, remember, the vena contracta is nothing but the liquid jet where the streamlines become parallel and perpendicular to the plane of the orifice is termed as vena contracta, and the cross section area of the jet at the vena contracta is less than that of the orifice. And generally this vena contracta will occurring at a distance of d by 2. Remember, at a distance of d by 2. Okay, so at a distance of d by 2. D means the diameter of orifice. So half of the diameter of orifice, if you measure the length, and at that particular point the vena contracta will be present. So okay, means vena contracta is nothing but the veins of the streamlines are get contracting, and at that particular region the area will be minimum. Okay, the area will be minimum, the velocity will be more. Okay, so that is that particular region is what we call as a vena contracta. Then again, after vena contracta, the jet diverges and attracted towards the gravity because of the gravitational force. Remember, only for a distance of d by 2, means if you are measuring the distance perpendicular to the plane of the orifice, that is half of the diameter of the orifice, at that particular distance the vena contracta effect will be there, where all the streamlines will be parallel to each other and they are perpendicular to the plane of the orifice, and also at that particular region the area will be minimum. Okay, I hope you understood this one. Let us move to the next part. Then the classification of orifice. The classification of orifice. The orifices can be classified based on various criteria. So here, based on the shape of the orifice, if you look at this based on the shape of the orifices could be a circular opening, or a rectangular orifice, square orifice, triangular orifice. You can look at the, it could be like this, or it could be rectangle, circle, triangular. Just here, just the opening provided on the side of the tank. This opening could be of any shape. It could be of any shape. It could be a square orifice, it could be a rectangular orifice, it could be a circular orifice, it could be a triangular orifice. Okay, and depending upon the size of the orifice, small orifice and a large orifice. Then how will you differentiate small orifice and a large orifice? If suppose in a tank, if you consider this is a tank, it is filled with a liquid, and this is the orifice you have fitted, and this is the diameter of the orifice. If you take the center of this orifice, from the center from the center, if you are measuring the depth in a tank from the center of the orifice, let us take this as the depth or height or the head of liquid from the center of the orifice till the free surface of water. If suppose this height is greater than or equal to 5 times the depth of the orifice, this height or this depth of a water in a tank is greater than or equal to 5 times the depth of the orifice, then that is called as a small orifice. Small orifice. Then large orifice means if depth is less than 5 times of d, that is the depth of orifice, then it is called as a large orifice. Means large, if the orifice is of bigger size, then the liquid will be coming out with a very fast. Okay, so it will coming with a very fast, then the depth is immediately get decreasing. Okay, then where h is the head above the center of the orifice and d is the diameter or size of the orifice. Then according to the downstream condition, means this is, if you take considering this as upstream side and this side as a downstream side, this is downstream side. According to the downstream condition or a nature of discharge, free orifice and again submerged orifice. Free means if it is discharging freely like this into the atmosphere, so what it is discharging freely into the atmosphere, it is called free orifice. And second is submerged orifice, means partially submerged and fully submerged. Means suppose if there is a tank, here, it is discharging the liquid from this tank to this tank. Then while discharging, this orifice is partially submerged into this tank. This is called as a partially submerged. If it is fully submerged into this tank, means if these two tanks are side by side like this, so this is one tank and both are at the same position, then this or through this tank the liquid is discharging into this tank. This is the level of liquid in this tank. So means if you consider this tank orifice is completely submerged into this tank. This is called fully submerged orifice. So like this, the classification of orifices will be made according to the shape, according to the size, and according to the downstream condition. Okay, I hope you understood this classification and all. So let us move to the next one, that is flow through an orifice. So this particular part will continue the next video lecture. Okay, I hope you understood the classification and the definition of vena contracta and introduction part. Okay, so again we'll continue next flow through an orifice. Okay, thank you.